Alright, the last thing is the measures of dispersion. Alright, which measures of dispersion means I have a mean, median, and mode. Alright, so I kind of know how the middle numbers are, right? The mean is my average, the median is my middle numbers. We've talked about how often one occurs. The last thing that you discussed in statistics is what we want to know, on average, how close or far away are most of my points from the mean, right? Are the points close to the mean? Are they spread really far away from the mean? All right. And so there's two ways to do that. First of all, the range, we find the range to see, well, all of my data points land within this range. Right? If the range is big, means the data points are spread way out. Right? If the maximum and the minimum values, when we take this suppress, so the range would be the difference between the max and min values. All right, the spread of the points. So all of my data points land within this distance. So my maximum value is 10, my minimum value is 20. All of my points are within 20, right? Because that's the range. Right, because my high and low are 30 and 10. Right, the next one, which is the one that is used the most often, is what's called standard deviation. Right, standard deviation measures how much the data values are spread from our mean, from our average. A smaller deviation means that most of the values are pretty close to our average. Right, they're clustered real close around the mean. A big deviation means we've got values that are maybe way out far away from it. All right, we've got some outliers maybe, or just a lot of numbers land far, far away from it. All right, there's a big deviation from the average. All right, so again, that's what the standard deviation means. A big number means the numbers are spread way out. A small number means the numbers are really tightly packed. All right, they're close together. All right, how we find it. Alright, again, we're going to do it by hand because not all calculators can find standard deviation. Alright, so if you have a simple scientific calculator, standard deviation is something that you'll have to do by hand. There are ways to do it on the more fancier calculators. And again, if you want to figure that out on your own, feel free. But we are going to learn how to do it by hand because all scientific calculators can do it by hand. And it's not that bad of a calculation. Actually, when I ask you to do it, I'll ask you to set it up in a table anyway, and so you're going to have to know how to do it by hand. So this is the method we're going to use. Alright, so the formula is, alright, so it looks like a really fancy formula. Alright, so what we do is we sort of break the formula down. And it is a fancy formula. What it is, again, we use Greek letters in math. Statisticians way back when who came up with these used Greek letters. And so the standard deviation is this sigma. It's sort of an O with a line on top. Alright, that's the standard deviation symbol. And so what we have to do is find the standard deviation as well. We find the square root of the sum. That's what that, remember that, the sum of the square deviations. Alright, divided by n, so the average value of the square deviations. And then we take the square root of it because we're undoing a square. And there's a reason why we do the square. I'm not going to go into great depth why, but it has to do with we want to avoid 0 is what we want to avoid. Alright, so in order to avoid 0, we have to square stuff to make them all positive numbers. Since we square stuff, we have to unsquare stuff. Alright, so what we're going to do is, in order to solve this, we're going to set up a table. Alright, and so we're going to sort of break down this complex formula into bite-sized pieces, so to speak, using a table. And this is the process that you'll be asked to do on the quiz and the test. Alright, so the data would be, so on the table we have the first column here, which would be all your points, and all your x values that you're given, all the number values that you're given in your set. Then the first thing you're going to do is you're going to find the deviation from the mean. That's what this deviation means. I'm going to find the difference between my value and the mean, right? This would be the number minus the mean value. That's what the deviation is. Since some of these will come out negative, we want to avoid negatives, and so this would be this. So the first thing we do is we find the deviations, which some of them would be positive because some numbers land above the mean, some numbers land below the mean. And so we square the deviation. We take that deviation we found here and we square it, so that's the last table, to get rid of the negative. So squaring allows us to get rid of the negatives. Alright, so then we'll have a list of all the square deviations. When you add up the square deviations, that's this part of the formula. That's the sum of the deviations squared. Alright, that's this. When I add up every number in that last column, and we'll do examples of this, that's my square deviation. And so that's that piece of the formula that we're sort of breaking down. Once you find the sum of the square deviation, then you plug that number into this part of the formula. You'll divide by n. N represents the total number. So n equals the total number of values, right? If we have 10 values, n would represent 10. If we had 3 values, n would represent 3. And then the last thing you do, after you do that division, the last thing you do is we want to undo, since we did this squaring here, we have to undo it to get to our deviation. And we have to take the square root of it. Alright, so the last thing you do is take the square root of it. Alright, and again, you do it all the very last so that there's no rounding until the very end of the problem. Alright, so the first example, like I said, I'm going to walk you through it, and this is what we're going to do. We're going to set up the table. Alright, so we're going to set up the table. The first thing is you can count 18, 20, 16, 4. Those are the x values. Those are the data values. There are 4 of them. So n represents 4. We're going to eventually find the standard deviation, which is the square root of the sum of the square deviations from the mean divided by n. So before I get started, the first thing I'm going to find is my mean, right? Because I know I need to find the mean. Right, the mu, right, which is the sum of my data values divided by the number of them, which is 4. So I add these up and divide by 4. Alright, so when I add them up, 18, 20, 16, and 14, that adds up to 68. Take my 68, divide by 4, and so my average, my mean, which is that mu symbol, is 7. And I need that because that's a part of the formula. Alright, so that's the first thing you do. Figure out how many numbers you have and find the mean of those numbers. Now we'll set up the table for the standard deviation table that we're going to use to solve. We're going to break down that formula in a table. Alright, so the first thing, there's column 1 are all my x values. Column 2 are my x values minus that mean, which we now know, so we're going to subtract 17 from all my values. And then the last one is taking whatever value is in this column and squaring it so that I get all positive numbers. So that's the square deviation. Alright, so this is the deviation, and then this is the square deviation. Alright, so first I list my values, and we like to list them in order, just because you don't have to, but as a mathematician we like to list them in order. So I'll go 14, 16, 18, and 20. Alright, the deviation is I do the subtraction, so I'm going to take 14. Alright, the deviation is we take 14 minus 17, and so the first deviation is negative 3. Alright, so negative 3 is the first deviation. Then the next one we'll take 16 minus 17, so that gives me negative 1. We'll take 18 minus 17, that gives me a positive 1, and 20 minus 17, which gives me a positive 3. And you'll notice, some of them are positive and some of them are negative, and they're the same values. If I added those values up, we get 0, which is why we can't use those values. So what they did is they figured out, well, we can square them, right? Because squaring them will get rid of the negative. And so now you square these. So you take your negative 3 squared, and squared should always give you a positive number. Your negative 1 squared will give you the positive number. 1 squared, and then 3 squared. And so those are the numbers that are my square deviation. Those are what we're going to add up to get the sum of my square deviations, to get that top part of the fraction in my deviation equation. And so you're going to add that. You're going to take 9 plus 9, so that's 18, plus 2 ones, which will give you 20. Alright, so 20 goes into that part of the formula, the top part of the formula. So now I'm going to fill out the formula. So my square deviation sum is 20, the top part. The bottom part I know is 4, because that's n, so it's going to be 20 divided by 4, and then the last thing you do is you take the square root of that. So you can either do it in that step, or 20 divided by 4. You can simplify that, or do it all in once. Again, one shot's fine. Do not round until the end of the problem, so if the fraction comes out ugly, leave it the fraction. So I just say, rule of thumb is just leave it, alright, because then you're less likely to make an error. So it's the square root of that fraction, and that should come out to 2.236, and again, whatever the test, quiz, or homework asks you to round to, make sure you round to it, but there is my standard deviation. And so what the standard, so that is the standard deviation. And so with the standard deviation, on average, my points vary by about 2.2. Right? That's what most of them land within 2.2 units of the mean. That's what it means. Most of them land within 2.2 units of the 17. And if you look at it, most of them do. Most of them are fairly close to the 17. All right, within 2 points. Now, next example. All right, so again, I've got 1, 2, 3, 4, 5 numbers, so n is 5. I'm going to find my mean first, right? My mu, which is the sum of all of my numbers divided by 5. So I add those numbers up. So my 50, my 38, my 42, 40, and 45 adds up to be 215 divided by 5. And so my average is 43. So my mean is 43, which again, I need that because when I go fill out this formula, remember the first thing we're going to do is find the sum of these square deviations divided by n. Again, we're going to do that using the table. Oh, and I forgot to find the range. We'll find the range first. I'll do that last. Hopefully I don't forget. I'm going to find my deviation first, and then the last thing I'm going to do is find my range. Alright, so we're going to use the table to set it up. So again, we've x values first in the table, then our deviations, x minus the mean, right? That's the deviation. And then the third part of the table is x minus the mean squared. So it's the square of the deviations. Right, the square of that second column, all of those numbers squared. All right, so again, I like to order mine, but you don't have to, but I like to put them in order. 38, 40, 42, 45, and 50. Alright, so first we find the difference, and so remember the difference is, and I just like put it in my table here, the mean was 43. So all of my x values I'm going to subtract 43 from. So I'm going to take 38 minus 43, well that comes out negative 5. 40 minus 43, that's negative 3. 42 minus 43, that's negative 1. 45 minus 43, that's a positive 2. 50 minus 43, that's a positive 7. Alright, and so there are all my deviations. Some of them are positive, some are negative. If I added them up, they would add up to 0. Which is why I have to do the next step, which I take each of those and square them. So negative 5 squared comes out to positive 25. Negative 3 squared comes out to positive 9. 1 squared is a positive 1. 2 squared is a positive 4. And 7 squared is a positive 49. Again, the deviation squared should always come out positive. So careful on your calculator when you're squaring it out. Put parentheses around the negative. Alright, now we're going to add these up because what we want to do is we want to find the sum of the square deviations, and so to do that, it's the, alright, that goes in our table, we add those up, so we're going to take the sum. So we take 25, add 9, add 1, add 4, add 49, and so that adds up to 88, alright, and that goes into that part of the formula. So when I go up here, I'm going to rewrite this as, this, I know the top part now, is 88, I know n is 5, and again, I just leave it because we don't want to round to the end, so I'm just going to leave it the square root of 88 divided by 5. Make sure the whole fraction is under the square root. And then type it out on the calculator. That comes out to be 4.195, around 4.2 would be my standard deviation. Alright, so there's the standard deviation. That's the hard part, the last thing, so I don't forget to find the range. Remember, the range is just the maximum value minus the minimum value. Alright, so the maximum value was 50. My minimum value was 38. So that's the range. My numbers land between 38 and 50, so that's the range. So my numbers land over a 12-unit span. Most of them, though, are within 4 points of the average. That's what this means. That's what this means here. Most of my values land within 4 points of the mean, which was 43. And if you look at them, most of them are pretty close to the mean. Alright, next example, or the last example, I believe. Alright, this is sort of putting it all together. Alright, the last example. So a golfer completed 6 rounds on a competition. Below are the scores for each round. So round 1, 75, to round 6, 79. Alright, so there are 6. So my n is 6. Alright, find the mean, mode, and the 5-number summary first. So mean, remember, is the sum of all my values divided by n. So we add all these scores up and divide by 6. So what was his average score for his 6 rounds? So add 75, 80, 72, 81, 75, 79. That adds up to be 462. Divide by 6. So his average was a score of 77. Right, his mode, he did 75 twice. Alright, that's the only one that shows up more than once, so 75. Alright, now the 5-number summary. Right, remember the 5-number summary is the low value, the maximum, the minimum, the mean, the first quartile, and the third quartile. In order to do the 5-number summary, we've got to list them. So I'm going to go ahead and put them in order to get my 5-number summary. So the low value is 72, then a 75, another 75, 79, 80, and 81. So there's my 5 numbers lined up. Alright, now I want to find, so the low number and the high numbers are easy, right? My maximum value is 72, my minimum is 81. So there's 2 of the numbers for my 5-number summary. Then I need to find my median, quartile 1, and quartile 3. Alright, so those are the ones I need to find. Alright, then we'll do the range. Alright, so the median is the middlemost number. Well, there's 6, so again, that means there are 2 values in the middle. So I want to find the value. There are 3, I go 3 in and 3 up, right? That would be the upper half. That would be the lower half. The median is the value in between those 2 numbers in the upper half, the 75 and the 79. Alright, so I'm going to go over here to do my work for the median. Alright, so the median would be taking the 75 plus the 79 divided by 2. It's the middle value between the 75 and the 79. And so that comes out to be 77. Right? Again, it's just a coincidence. I have it to be the same as the mean. That doesn't always happen. It's just a coincidence. Alright, so 77 is in between. And again, that shouldn't be 6. 77 is halfway between 75 and 79. Alright, so now I've got my median. Now I need the halfway point between my high numbers and my low numbers. Alright, so this one's a little easier because 6 is kind of nice because there's 3 above and 3 below. So there's 3 in my upper half and 3 in my lower half, which means there is just one middle value in the lower half. That's 75, and the upper half, that's 80. So my first quartile, 75. My third quartile is 80. Just curious, that would be quartile 2. Alright, so there's my 5-number summary. Alright, the next thing we ask for the range, which is the high value. I did these backwards. The high value is 81. The low value is 72. Make sure you correct that. Maximum is 81. Minimum is 72. Alright, the range is the difference between the high value and the low value. So I take my 81 minus my 72. And so the range is 9. Then the scores all land within 9 points of each other. Alright, I'll land in a range of 9 points between the high and the low. Alright, so there's the range. So that's the last thing one of the last things we talked about. And the very last thing is the standard deviation. Alright, so standard deviation remembers that formula, the sum of the square deviations from the mean divided by n. So remember, n was 6. The mean we found earlier, which was 77, those 2 values I need. Alright, in order to simplify this, we break it down using a table. Alright, so the scores, his deviation from his mean, which we know is 77. So we're going to subtract 77. And then the square of that, x minus the mean squared, which is what we want to get to so that we can add those up and put them in our form. Alright, so we do like to put them in order, so 72 and then 75, and you put down both 75s. 79, 80, 81. Alright, so the first thing you can do is find the, so you're going to take 72 minus 77, so that's negative 5. 75 minus 77, that's negative 2, so that's also negative 2. 79 minus 77, that's a positive 2. 80 minus 77 is a positive 3. And 81 minus 77 is a positive 4. Again, I don't want to add those up because I've got negatives and it'll zero out, so I've got to square them. So over here, we square those numbers. 5 squared is 25. Then we've got 4, right? 2 squared is 4, whether it's negative or positive. 3 squared is 9. 4 squared is 16. And there's my square deviations, which this is what we want to take the sum of. We want to add those up because that's the sum of my square deviations, which is the piece of the formula I want. So you take your 25, add the 4s, add the 9, add the 16. That adds up to 62, and that goes into this formula. Alright, so my standard deviation is the square root of 62. Forgot what it was for a second. 62 divided by n, which was 6. So again, I just leave it exact. Square root of 62 divided by 6 comes out to be 3.2145. So I'm just going to round 2 decimals. 3.2 is my due. So his average is a 77. Most of his scores are within 3 of that. So it means most of his scores land between 80 and 74. Alright, if you look at them, most of them should land between 80 and 74. Alright, so that finishes up the last of the 6.1 notes.